Good morning, dear students. In our previous lecture, we have gone through various reversible electrodes. In today's lecture, we will continue with the topic, the measurement of standard electrode potential of a single electrode. Now, standard electrode potential of a single electrode is determined by connecting the given electrode to some reference electrode. Now, what do we mean by this reference electrode? The reference electrode is defined as the electrode which has accurately known electrode potential at 298 Kelvin and is used to find out the single electrode potentials of the other electrode. So, reference electrodes are the electrodes whose electrode potentials are arbitrarily fixed. We will connect the given electrode to the reference electrode and find out the EMF of the cell, and from the EMF of the cell we will be able to find out the electrode potential of given electrode. Now, the commonly used reference electrode we use for this purpose are, first one is standard hydrogen electrode whose standard electrode potential is arbitrarily taken as 0, whereas second one is the calomel electrode. Now, how we will measure the electrode potential? Now, standard electrode potential of an electrode can be calculated by using this equation. We are connecting that electrode to the reference electrode and measuring the EMF of the cell under the standard condition. That's why we will call it as standard EMF of the cell. And the standard EMF of the cell is given by the standard oxidation potential plus standard reduction potential, where the standard oxidation potential is of oxidation half reaction and standard reduction potential is of reduction half reaction. In general, we take the electrode potential in terms of reduction potential. As per standard convention, we generally take the electrode potential in terms of reduction potential. So, we will mainly use this formula, that is EMF of the cell is equal to standard reduction potential minus standard reduction potential of oxidation half reaction and plus standard reduction potential of reduction half reaction. As we know, the standard reduction potential of cathode will be higher than the standard reduction potential of anode. So, the formula will be the standard EMF of cell is equal to standard reduction potential of cathode minus standard reduction potential of anode. So, we will use this formula to find out the standard electrode potential of the given electrode. So, what we are doing here, we are connecting the given electrode to the reference electrode and finding out the EMF of the cell. EMF of the cell is given by the reduction potential of cathode under the standard condition minus reduction potential of anode under the standard condition, or you can say EMF of the cell will be equal to standard reduction potential of cathode minus standard reduction potential of anode. For example, we can see this cell in which on the left hand side the zinc rod is dipped in the zinc sulfate solution, and on the right hand side we are connecting this zinc electrode to the reference electrode which is standard hydrogen electrode. Now, when we are connecting the zinc electrode to the hydrogen electrode, what you will see, the reduction is taking place at the standard hydrogen electrode and oxidation is taking place at the zinc. So, zinc is behaving as a node, whereas SHE, or you can say standard hydrogen electrode, that is behaving as cathode. So, the half reactions taking place at anode and cathode will be zinc is releasing 2 electrons to give zinc 2 plus, whereas at cathode 2H plus are taking 2 electrons to give hydrogen. So, this is the representation of this electrochemical cell in which we are having zinc in contact with the zinc 2 plus ion, and this is connected through the salt bridge to the standard hydrogen electrode. Now, other reference electrodes we can use, that is the calomel electrode. Now, the reduction potential of this calomel electrode at 25 degrees Celsius will depend upon the concentration of KCl solution taken in the calomel electrode. For the different concentration of potassium chloride solution, the reduction potential of calomel electrode under standard condition will be different. So depending upon the concentration, its reduction potential is different. We will take the same value which is corresponding to the given concentration we have taken in the calomel electrode. Now first one is the determination of electrode potential of an electrode using standard hydrogen electrode as a reference. Suppose in the previous slide we have taken zinc electrode is connected to the hydrogen electrode. In that case, EMF of the above cell has been found to be 0.76 volt. So this EMF of the above cell will be equal to reduction potential of cathode minus reduction potential of anode, or you can say reduction potential of cathode plus oxidation potential of anode. Now EMF is equal to 0.76, that is equal to oxidation potential of anode plus 0. So from here we are getting the oxidation potential of anode, that is equal to 0.76 volt. So 0.76 volt is the standard oxidation potential of zinc electrode, and if we talk about this reduction potential, then its value will be negative. So this is the 0.76 volt is the standard oxidation potential of zinc electrode. Its standard reduction potential will be equal to minus 0.76 volt. In case of reduction potential, we will write it as zinc 2 plus, then forward slash and then zinc. We will write it in reverse manner, then we will talk about the standard reduction potential. By convention, we are taking the potential of standard hydrogen electrode as a 0.0 volt at all temperatures. That's why we have taken here the 0 for SHE standard hydrogen electrode. Now determination of electrode potential using calomel electrode. In this case, we will connect the given electrode to the calomel electrode, where calomel electrode will be used as a reference electrode. So in the present picture or in the present figure, what we are seeing here, the copper electrode is connected to the calomel electrode, and when it is connected, we are seeing here the reduction is taking place at the copper, whereas oxidation is taking place at the calomel electrode. Now EMF of the above cell has been found to be 0.018 volt. So that will be equal to the sum of oxidation potential of calomel and reduction potential of copper, as the reduction is taking place at the copper and oxidation is taking place at the calomel. Now the reduction potential of calomel is 0.280. As we are talking here about the oxidation potential, so we can write it as negative. So minus 0.280 is the oxidation potential of the calomel. Suppose the reduction potential of this copper electrode is X, which we have to find out, and EMF of the above cell is 0.018. From this we can get the X is equal to 0.298 volt. So this will be equal to the standard reduction potential of copper electrode, and that is found to be 0.298 volt. As the reduction is taking place at copper, thus 0.298 volt is the standard reduction potential of copper electrode. Next is the electrochemical series we will do in the next lecture.